11.3 independent events. I can calculate independent events.
Hamza, what is an independent event?
Separate events that do not impact other events.
Separate events that do not have any impact on any other events. If you took notes in that first set of notes, the first group that took notes with me, this is a little bit different, although you have all of this in there. We already know that probability is favorable events over total events, right? Let's review. This right here, my friends, was the brand new learning for today. To calculate independent events, you're going to multiply the first event, which is event A, event 1, times the second event, which is event B, and that will give you your probability for 2 independent events. Got it? It's also on the cheat poll. If you look over at the cheat poll, we have that. Or actually, both of those formulas listed. Moving down to number 3, I'm just going to walk through this problem. Problem number 4. I have a yellow card. I have a second yellow card. I have a third yellow card, and I have a blue card. Everybody, on your toes here. What is the probability that I would randomly select a yellow card from this set of 4? Go.
3/4.
3/4. Everybody, what is the probability if I put that yellow card back? What is the probability that in my second draw, I would select a blue card?
1/4.
1/4. Now that I know that I have a 3 out of 4 chance of selecting a blue on the first draw, a 1 out of 4 chance of selecting a blue on a second draw, what do I do to those two numbers, you guys?
Multiply.
So we multiply 3/4 and 1/4, and what is the probability of selecting a blue card followed by a yellow card?
3/16.
Could you convert that to a percentage if you wanted to?
Yeah.
Yes, we didn't do that, but you could easily do that with all of your knowledge you have now. The last thing I want to point out is I'm not going to go through this entire problem, boys, but we talked about drawing cards, and we talked about that based on the situation and the problem above that you can review on your own time. There was a 12 out of 52 chance of drawing a face card and a 26 out of 52 chance of drawing a red card. What we did is we took this 12 over 52 and we reduced it to 3/13. That seem like a good idea? We took this 26 over 52 and we reduced it to 1/2. That seem like a good idea?
Yep.
Then we multiplied 3/13 times 1/2 to get our answer of 326. Seem like a good idea? Would you rather multiply 3/13 and 1/2, or would you rather multiply 12 50-seconds and 26 50-seconds?
The second one.
So is reducing not only your answer important, but reducing before you even get to your answer important as well? Yes or no?
Yeah.
Honey, is that really, really, really important to reduce before you even get to the answer? Can you always reduce fractions? Can you always reduce fractions if they're in a problem and they're reducible?
Yeah.
So if I gave you like 9/12 times 2/5, could you reduce 9/12 before you multiply it?
Yes.
Does 9 over 12 reduce?
Yes.
What?
3/4.
3/4. Thank you, Kennedy. Can you reduce 2/5?
No.
So is 3/4 times 2/5 the same thing as 9/12 times 2/5?
Yes.
They're the same thing. Would you rather multiply this or this?
The second one.
You would rather multiply that one, right? Because it's a lot easier to multiply 3 and 2 and 4 and 5 as opposed to 9 and 2 and 12 and 5. Even though I know you can do both because you're super smart. Does that make sense? Questions, comments?